Hello students of class 8. Today we will learn chapter 3 squares and square roots. Here we will mainly focus on two topics, that is square numbers and square roots of numbers. Let us now learn about square numbers. Under these there will be four subtopics. First will be definition, second will be how to find out perfect square numbers, third will be properties of square and squared numbers. Fourthly, it will be square of integers and rational numbers. When you read the definition, it is given as a square number is the result when a number has been multiplied by itself. In simple terms, it means that the product or answer that we will get when we multiply a number twice. The product or answer is the square number of that particular given number. This we can explain using some examples. 1 square equal to 1 into 1 is equal to 1. Here we see this 1 is the square number of the given number 1. Another example, let us see 5 square equal to 5 into 5 equal to 25. Here we can say 25 is the square number of the given number 5. Same with 13 square equal to 13 into 13 equal to 169. In this case 169 is the square number of 13. In this box I have highlighted exercise 3.1 question number 1 and 2. It means that exercise 3.1 question number 1 and 2 can be solved using this formula. Some more examples we will learn using negative signs. If somebody asks you to find out square of minus 1, you will write it as minus 1 whole square equal to minus 1 into minus 1. You will get answer as plus 1, as we have already studied in previous classes that minus into minus is plus. Take another example, minus 5 whole square equal to minus 5 into minus 5. You will get answer as plus 25. Minus 13 whole square equal to minus 13 into minus 13 equal to plus 169. So whenever you are squaring a negative number or a number with negative sign, the answer you will get is positive. When you are asked to find square of a given number, then always remember the base will be according to your question, but your power will always remain as 2. Suppose, take this example, square of 2. If you are asked to find out square of 2, you will write it as 2 to the power 2, or we read it as 2 square equal to 2 into 2 equal to 4. Now take this next case. If you are asked to find out square of 10, you will write it as 10 to the power 2 or 10 square, which is equal to 10 into 10 equal to 100. Same things apply for even negative numbers. You will clearly see here it is mentioned the base changes, but the power will always remain constant as 2 in case of square numbers. Here we will learn to find out whether a given number is perfect square numbers or not. It is clearly written a number is said to be perfect square if it is expressible as a product of pairs of equal factors. To understand it more clearly, we will take an example, a number 196. Now we have to find out whether 196 is a perfect square number or not. For that, what you have to do first, you have to factorize 196 using prime factorization method. Now 196 we can divide it by 2, we will get 98. Again we divide it by 2, we get 49. Now 49 we can divide it by 7. So we can write 196 equal to 2 into 2 into 7 into 7. From here, let us make pair of 2 and 2, 7 and 7. From both the pair, let us take one number each, 2 and 7, equal to 2 into 7 is 14. So we can say that 196 is a perfect square of 14. To check whether 196 is a perfect square of 14 or not, you just multiply 14 into 14 and see whether you get the answer as 196 or you get any different answer. If you get any different answer, that means somewhere in calculation you have done mistake. If you get correct answer, then that number is perfect square. Let us take another example, say 450. We have to find out whether 450 is a perfect square number or not. Same process we will follow, we will factorize it. 450 divided by 2, you get 225. Then divided by 3, you will get 75. Again 75 divided by 3, you will get 25. 25 divided by 5, you will get 5. Now you group it as 450 equal to 2 into 3 into 3 into 5 into 5. Here you will see 3 and 3 is pair, 5 and 5 is pair. But this number 2 doesn't have any pair, it is left ungrouped. Since one number doesn't have a pair, that is number 2, then 450 is not a perfect square of any number. Sometimes you may get questions like, if a number is not a perfect square, then find out smallest number which will be multiplied to that given number to make the number a perfect square. So to know more about this, we will take the same example from previous one, that is 450. As we already know that 450 is not a perfect square as 2 was left ungrouped. So in this case, let us make the question like this. Find the smallest number to be multiplied to 450 to make it a perfect square. We already know that left out number was 2. So what we will do, we will multiply both sides of the equation with 2. So here we will see 450 into 2 equal to 2 into 2 into 3 into 3 into 5 into 5. So here what we have multiplied both sides, here these 2, and we have multiplied another 2 here in both left and right hand side. So what we will get, 900 equal to 2 into 3 into 5, which is equal to 900 equal to 30. So now we can say that 900 is a perfect square of 30. If you want to check whether you have got correct answer or not, you can do 30 into 30 and see whether you will get perfect square or not. So here in this case we see that 30 into 30 is equal to 900. So how you will write your answer, it should be written as the smallest number required to be multiplied to 450 to make it a perfect square is 2. You will not write 900 is the smallest number. If you write 900 is the smallest number, it will be wrong. We just have to find out the smallest number that is required. So which number we have multiplied with 450? The number is 2. Then it became 900. So 900 is perfect square number of 30. Properties of square and squared numbers. Firstly, we will study the properties of square numbers. Here there are 6 properties that are given. You can go through it in detail. We will explain it in next slide. First property we see it is written as square of even number is even. So what does that mean? Before going that, you first see here any number that can be exactly divided by 2 without leaving any remainder is called an even number. So now you are clear with even number. Here you can see if you are asked to find out square of 2, 2 is an even number. So when you are asked to find out square of 2, the answer that you get is 4. 4 is also an even number. Suppose you are asked to find out square of 14, as 14 is an even number. The answer you get is 196, that is also an even number. Again take this square of 134, answer you are getting is 17,956, which is also an even number. So whenever you multiply a same even number twice, the answer that you get will also be an even number. Second property that is given is square of odd number is odd. Before explaining the example, let me first explain you what is odd number. Any number that cannot be exactly divided by 2 and leaves remainder, it is an odd number. So here we can see square of 3. 3 is an odd number. The answer that we get is 9. 9 is also an odd number. Square of 13, we get 169. Both are odd numbers. Square of 131, we get the answer as 17,161. Here both the number and the answer that we get is also an odd number. This is what it means, that square of an odd number is odd. Third property is square of number having 5 in ones place will have 5 in ones place. For better understanding, I have given here ones place refer to the n digit. That means if you take a number, say square of 25. 25 is a number that ends with 5. The digits in one place is 5. So the answer that you get is 625. Even in this answer, you see the ones place have digit 5. Same here, square of 45, you will see 2025. So this means if a number ends with 5, then even the square of that number will end with 5. Now let us go to next property. Square of number having 0 in ones place will have 0 in ones place. Here you will see in ones place there is 0. Square of 10. The answer that you get when you square 10, you get 100. Even in its one place, it is 0. Square of 300. Here ending with 0, you get 90,000. Even the answer ends with 0. Now property 3 and 4, if you compare and see, both are similar. In third, it is written if a number ends with 5, even the square of that number will end with 5. In fourth property, they have said if a number ends with 0, then even the square of that number will end with 0. The fifth property states the square of a natural number n is equal to the sum of first n odd numbers. Here, this n depicts any natural number. So if you find out square of 5, you get 25. This property means that if your number is 5, then the sum of first 5 odd number will also be 25. So the first 5 odd number is 1, 3, 5, 7, 9. You can count 1, 2, 3, 4, 5. So when you add these 5 odd numbers, you get the result as 25, which is same as the square of 5. Let us take another example. Square of 6. Square of 6, we get 36. So if we add first 6 odd numbers 1, 3, 5, 7, 9, 11. The answer that we get is 36. The sixth property states, for every natural number n, n plus 1 whole square minus n square is equal to n plus 1 plus n. Here, if we take the natural number n as 5 and put in the left hand side of the formula n is equal to 5, we get n plus 1 whole square minus n square as 5 plus 1 whole square minus 5 square equal to 5 plus 1 is 6, 6 square minus 5 square we get 6 into 6 36 minus 5 into 5 25. The answer is 11. Now taking n equal to 5 in right hand side of the formula we get here n plus 1 bracket close plus n, we take it as 5 plus 1 bracket close plus 5 equal to 6 plus 5 equal to 11. So we see that both left hand side is equal to right hand side is equal to 11. So this property for every natural number held true. Now this is properties of square numbers. You can find this in page number 32 of your textbook. These 5 properties you can go through for your understanding. This is the last subtopic of square number, that is square of integers and rational numbers. Here we will see 2 by 3 whole square is equal to 2 by 3 into 2 by 3. 2 into 2 we will get 4, 3 into 3 we will get 9, so the answer is 4 by 9. Same number with negative sign, minus 2 by 3 whole square equal to minus 2 by 3 into minus 2 by 3 we get plus 4 by 9. As we have already studied, minus into minus is plus. Same goes with decimal. If we are to write 1.5 whole square equal to 1.5 into 1.5 we will get 2.25. Similarly, if it is minus 1.5 whole square we will write equal to minus 1.5 into minus 1.5. Minus into minus will become plus, we will get plus 2.25. Exercise 3.1, question number 8 is given as express each of the following perfect square as sum of odd numbers. So question number A, we will take 64. We know 64 is a perfect square of 8. So we have to show that 64 is also sum of first 8 odd numbers. So we will take here first 8 odd numbers 1, 3, 5, 7, 9, 11, 13, 15. When we add all these, we will get the answer as 64. Now question number 9 we see, without adding, find the sum of number A is 1 plus 3 plus 5 plus 7 plus 9 plus 11. So without adding, how you will find out? According to question, we see that there are 6 odd numbers 1, 2, 3, 4, 5 and 6. So what you will do, instead of adding all these, you will write, since there are 6 odd numbers, you will write 6 square is equal to 6 into 6 equal to 36. Question number 10, it is given, observe a pattern and find the missing number. Here they have given 3 patterns, 1 square plus 2 square plus 2 square equal to 3 square, 2 square plus 3 square plus 6 square is equal to 7 square. 3 square plus 4 square plus 12 square equal to 13 square. So these patterns they have given, they ask us to observe and find the missing numbers. So when we observe, we see the pattern as n square plus n plus 1 whole square plus n into n plus 1 here whole square equal to n into n plus 1 whole square. The pattern follows this. If you want to understand this in simple terms, then just see this first number, you take it as n. That's 1. Now when you take this 1 as n, you see that n plus 1, that is 1 plus 1 is 2. And when you multiply 2 into 1, you will get here 2. And your right hand side is 1 more than this 2. Go for another pattern. You see here, this is your 2. When you add 1 more, you get here 3. When you multiply here 2 into 3, you get 6. Now 6 plus 1, you get here 7. Same way, see here 3. 3 plus 1 is 4. 3 into 4, you get here 12. And here 12 plus 1, you will get 13. So same pattern you will follow. For explaining in detail, for the first one, let us take n as 4. As it is given in your question, 4 square plus 5 square plus dash square equal to 21. So here we will take n as 4. We see that n plus 1 whole square plus n into n plus 1 whole square equal to n into n plus 1 whole square. So wherever there is n, you substitute it with 4, you will get 4 square plus 4 plus 1 whole square plus 4 into 4 plus 1 whole square equal to 4 into 4 plus 1 whole square. So you will get as 4 square plus 4 plus 1 is 5 plus 4 into 5 whole square equal to 4 into 5 plus 1 whole square. And then you will get 4 square plus 5 square plus 20 square equal to 20 plus 1 whole square. Then at last you will get 4 square plus 5 square plus 20 square equal to 21 square. So the missing number is 20. Same you will use to find out the other missing numbers. You can directly find out without solution here, as they have given here 5. So 5 plus 1 will be 6. That is your missing number. 6 into 5, you will get 30. 30 plus 1 is 31. The next one you will see 6 plus 1 is 7. 6 into 7 is 42. 42 plus 1 is 43. So this will be your answer. That's all for today. Remaining topics we will learn in next class. Thank you.